Passage 5 is a research summaries passage, and students were studying electrical forces between conducting spheres. So there are these spheres right here that, when brought close to each other, would move away from each other. And what they would do is they would twist this vertical wire, and what students were measuring was how far or what angle, theta, that those spheres moved away from each other. And they changed things like the radius of the conducting spheres, how far they were from each other, and the charge on the spheres to see how they behave differently. So 24 is asking, according to the results of study 1, as d increased, or the distance between the conducting spheres increased, what happened to theta? So study 1, that angle, well, as the angle, as the distance increased from 10 to 40, the angle was decreasing. So as d increased, the angle theta decreased only. For 25, the amount of charge the students initially placed on sphere A using the charging probe was the same for all the trials in which of the studies. So we need to see where the charge on sphere A was the same. Well, they put a charge of negative 7.5 times 10 to the 9th coulombs on the sphere for study 1. They did the same on sphere A for study 2, and they also did that same charge for sphere A on study 3. So all studies had that same charge. The answer for 25 was D. 26, suppose that in study 3 an additional trial had been performed with sphere A mounted on stand 1 and sphere H, a sphere with a radius of 0.7 centimeters, mounted on stand 2. So based on the results of study 3, theta for that trial would most likely be what? So for study 3, we want to look if we had a sphere of 0.7 centimeters in radius. 0.7 will be somewhere between 0.95 and 0.48. And you can see that as the radius increases, theta increases. And so we need to be somewhere between 11 and 8 for our angle, since 0.7 is somewhere between 0.95 and 0.48. So the only answer that fits there is H, between 8 degrees and 11 degrees. For 27, suppose that in any of the trials in studies 1 and 2, the students had placed a positive charge on sphere B. Now remember, in both of those studies, they were placing two charges that were the same, both positive charges. So it's asking how would the direction of motion of sphere B have been affected. So what they were doing in these charges, they were placing, not a positive charge, a negative charge, but they were the same charges. And that would cause those spheres to move away from each other because like charges repel. So it's asking if you had, instead of two like charges, you had a positive and negative. Well, we know opposites attract. So they would move towards each other because opposite charges attract. They don't repel, they attract. So 27 would be C. For 28, the result of study 2 are best represented by which of the following graphs? So study 2, I'll look at the data here. When Q, which is the charge, becomes more negative, goes from negative 0.9 to negative 1.9 to negative 3.8, so it's becoming increasingly negative, theta increases positively. So if we look at 28, as theta, which is on our as Q in coulombs becomes more negative or moves this direction, theta, which is in our Y, increases. So this is our trend, letter G. And then our last question, 29, during a given trial, while the two charged spheres move apart, the potential energy stored in the vertical wire most likely does what? So when those spheres moved apart, they had this diagram showing that this vertical wire would twist. And when it twists, it gains potential energy. So as the spheres moved apart, since it's becoming more twisted, potential energy would increase because of that wire being more twisted.